Okay, subtracting fractions from lesson 9-5. Remember, when you're subtracting fractions, it follows the same rule as adding fractions. The denominator stays the same, we just use the numerators. 9/12 minus 3/12 is 6/12. 17/10 minus 9/10 would be 8/10, and I could check these by adding this plus this, and it would equal this. This plus this should equal this. People in class have been asking, what if the denominators are not the same? We're not worrying about that. We're not going to see that this year. Anna walks her puppy 3/5 of a mile every day after school. How many miles does she walk her dog in 7 days? Well, if I have 7 days and each one is 3/5, I'm going to add 3/5 7 times. That's 4, 5, 6, 7. Oh, it should be a 5. One day, 2 days, 3 days, 4 days, 5 days, 6 days, 7 days. So I could skip count by 3s. 3, 6, 9, 12, 15, 18, 21. So this equals 21/5, right? This is not wrong, but it's improper. It's an improper fraction, and we've learned that we don't like to leave those. We like to convert them into mixed numbers. So a couple of ways to do this. The way that I like best is to decompose it. I could write 1/5 21 times, and then circle groups of 5, because I know in this example, 1 whole is equal to 5/5. But instead of circling groups of 5, I can just start by going like this. 5/5 plus 5/5 means I have 10/5. Another 5/5 makes 15/5. Another 5/5 makes 20/5. And I can't do another group of 5/5 because I only had 21, so I would have 1/5 left over. This is 1 plus 1 plus 1 plus 1 plus 1/5, or 4 and 1/5. The other way to do this would be by dividing 21 divided by 5, and we skip count by 5s. 5, 10, 15, 20. 25 is too far, so I use the math fact 5 times 4. So I know there's 4 whole groups of 5, just like we see here. And to get from 20 to 21, I would find my remainder of 1, which is the numerator. Okay, same work, just a different way to show it. I think the decomposing fractions is really nice, but whatever makes sense for you. All right, improper fractions to mixed numbers. I'm going to model 2 of them, and I'll let you work on the last one on your own. All right, so in this example, 1 whole is equal to 2 halves, or 2/2. So for 19 halves, I would have 2/2 plus 2/2. That makes 4, plus 2/2, 6. That's 8 halves, 10 halves, 12 halves, 14 halves, 16 halves, 18 halves. Oh, the next one would be 20 halves, which would be too much. This is 2, 4, 6, 8, 10, 12, 14, 16, 18 halves, and I would have 1 half left over. So this is 1 whole, 2 wholes, 3 wholes, 4 wholes, 5 wholes, 6 wholes, 7 wholes, 8 wholes. Oop, that should be a 2, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 1 half. Right? Or I could have skip counted 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 is too far. So I get my 9 wholes because this is 2 times 9, and I have 1 left over, 1 half block left over. For 7/5, I would say to myself, in this example, 1 equals 5/5, right? I take that from my denominator. I can do 5/5. Oh, another group of 5/5 would be too much. It would bring me to 10/5. I only have 2/5 left over, so this is 1 plus 2/5, or 1 and 2/5. If I skip counted, it would be 5, 10, oh, too far. Okay, so one group, and then I would count 6, 7, so there's 2 1/5 blocks left over. You can do this one for practice on your own, and we can check it in class on Monday. Mixed numbers to improper fractions. I think this is pretty easy also, as long as you follow this step. In this example, 1 whole is equal to 6/6. So this 1 whole is 6/6 plus 1/6. 6/6 plus 1/6, it couldn't be any easier. 7/6. In this example, 1 whole is equal to 2/2. Pretty easy, right? This is 2 wholes, so it's 2/2 plus 2/2 plus 1/2. 2 plus 2 is 4, 4 plus 1 is 5, so it's 5/2. In this example, 1 whole is equal to 3/3, so this is 3/3 plus 3/3 plus 1/3, or 7/3. This step makes this so easy. Please follow that step. All right, I'll do 2 of these and 2 of the subtraction in a new video.